Welcome to this explainer. Today, we're taking a journey to trace the incredible evolution of the internet. We're talking a massive leap from deeply secretive Cold War experiments using giant room-sized vacuum tube computers all the way to the massive global network that invisibly connects billions of us today. It is arguably the single most transformational technological leap in human history. And trust me, understanding how it was built, piece by literal piece, is absolutely going to change how you look at the device you're holding right now.
So to really understand where we are, we have to jump back to the very beginning with one fundamental question. Could computers actually communicate across the globe? Back in the late 1950s, catalyzed by the launch of Sputnik and the creation of ARPA, scientists locked away in secure government facilities were asking themselves this exact thing. And they weren't looking to share photos, right? They were trying to solve the incredibly urgent problem of distant communication during a deeply uncertain time.
Section 1. The Cold War Catalyst.
The intense environment of the Cold War really accelerated this desperate need to share information across long distances between completely isolated mainframes. The absolutely crucial breakthrough here was something called packet switching. Instead of sending a massive clunky file down a single vulnerable telephone circuit, you break the information down into these tiny data packets. Each packet then travels efficiently and independently through different network routes before seamlessly reassembling at the final destination. The whole idea was for it to be decentralized, meaning if one city was, say, destroyed in a nuclear strike, the data would just smartly route around the damage and find its way home.
Section 2. Connecting the first computers.
All right, so with theory firmly established, it was time to build the actual network. This ambitious step led to the launch of ARPANET, linking university research labs back in 1969. Now, the very first message they meant to send over ARPANET was just the word login. But famously, the system completely crashed after just 2 letters, LO. The crash happened because the receiving Stanford computers suffered a memory buffer overflow from the UCLA transmission. But you know what? Despite the crash, the researchers staring at that primitive little terminal knew they had just witnessed history. Distant computers really could communicate.
Section 3. Making networks speak.
As more of these research networks started popping up all over the place throughout the 1970s, a massive new challenge reared its head. We had all these distinct computer networks, but they were essentially like separate islands. They couldn't share a common language. The brilliant solution to this was TCP/IP, a universal communication framework developed by researchers like Vince Cerf and Robert Kahn. When ARPANET officially adopted TCP/IP, it allowed totally different networks to seamlessly exchange those data packets. That transition happened on January 1st, 1983, a date famously known in tech history as Flag Day, marking the exact moment the true foundation of our modern internet was born.
But as the network expanded globally, trying to route things using these incredibly long, clunky numeric IP addresses became just a nightmare. To fix this very human problem, the Domain Name System, or DNS, was introduced in the 1980s. It basically swapped out those difficult numbers for easy-to-remember names, making navigation across this wildly growing directory actually human-friendly for the very first time.
Section 4. The World Wide Web.
By the late 1980s, the network was vast. It was bridging continents and crossing borders, but it was still highly technical. Actually, it's a super common misunderstanding to use the internet and the web interchangeably. They are definitely not the same thing. The internet is the underlying physical roads, the cables, and the protocols like TCP/IP. The World Wide Web, which was proposed by British computer scientist Tim Berners-Lee in 1989, is simply a service built on top of those roads. It used hyperlinks to connect documents together, magically making information visually accessible rather than just raw data. And with the invention of the web came the tools to actually view it. Once early graphical web browsers like Mosaic hit the scene, along with dial-up modems, the internet totally transformed. It finally moved out of specialized European research labs and directly into ordinary family homes. Picture it, families gathering around these heavy glowing CRT monitors, listening to that iconic screech of a phone line connecting, and suddenly being able to explore a whole digital world through clickable links.
Section 5. Boom, Bust, and Web 2.0.
This newfound public accessibility in the 1990s didn't just change technology, it sparked an absolute cultural and economic revolution. The late 90s saw an unprecedented investment boom into literally anything with a .com name. And sure, when the bubble inevitably burst around 2000, lots of companies collapsed spectacularly. But interestingly enough, the underlying infrastructure, the physical cables and the actual user base, just kept growing without missing a beat.
And out of the ashes of that crash came a massive paradigm shift. We completely evolved from being passive consumers just reading static pages to becoming interactive creators driving Web 2.0. Suddenly, we were sharing photos, writing blogs, and building global communities. Then, by the 2010s, that entire interactive ecosystem migrated straight into our pockets via smartphones. The internet was no longer a destination you sat down to visit at a desk, it was just with you, everywhere you went.
Section 6. The Modern Cloud Era.
Now, supporting billions of people simultaneously using mobile apps, streaming video, and uploading interactive media requires a mind-boggling scale of hardware. Behind the sleek screens of every app you use today is this enormous, hidden physical reality. We're talking massive cloud computing data centers extending into the darkness, with millions of server racks humming alongside heavy-duty cooling systems. And here's a wild fact for you. Despite the popularity of global satellite ecosystems today, roughly 99% of all international data traffic still travels through physical fiber optic cables snaking along the bottom of the ocean. So the cloud isn't actually up in the sky at all. It's deeply grounded in these incredible feats of modern engineering.
The internet has completely changed how humanity communicates, learns, works, and connects. What began as a tense experiment between a handful of room-sized machines has literally wrapped the globe in light and data. But as we look up at this incredible digital world, it's absolutely crucial to remember that its story is still being written. The network is always evolving. So looking back at how incredibly far we've come, what do you think the next chapter will look like? Thanks for joining me on this explainer, and keep questioning the technology around you.